In this video, I am going to solve the problem 30th from chapter 19. Under constant pressure, the temperature of 3 mole of an ideal monoatomic gas is raised 15 Kelvin. What are the works done by the gas, and what is the energy transferred as heat, and what is the change in internal energy of the gas, and what is the change in the average kinetic energy per atom? So we have 4 questions here, so we have to answer one by one. So first of all, I'm going to write what is given in the question. So in the question, they clearly mentioned the process. So here, what is the process? Thermodynamic process. The thermodynamic process takes place at constant pressure. It's clear, right? So they mention it is at constant pressure. Okay. And then the number of moles of gas they mention, which is N equal to 3 mole. And they mention this is an ideal monoatomic gas. And its temperature they mention. So rise means its change in temperature. They mention here as 15 Kelvin. So we are going to find for 4 answer. In the first part, we are going to find the answer for the work done. And in the second part, we are going to find what should be the heat energy transfer. And the third one, we are going to find what is the change in internal energy. And the fourth one, we are going to find what is the average kinetic energy. What is the average kinetic energy we are going to find? So now we have to answer one by one. So let's start with the first question. So what is the first question? We are going to find what is the work done by the gas. So they clearly mention the thermodynamic process takes place at constant pressure. So if it is at constant pressure, we studied the rule work done, which is equal to P delta V, right? Okay, now we don't have any information about the pressure as well as the change in volume, but they clearly mention in the question it is an ideal monoatomic gas, so we can deal with the ideal gas equation. What is the ideal gas equation? As we already studied, PV, which is equal to nRT, right? So I'm going to, because here the pressure is the constant, only the change in variable is the volume as well as the temperature, right? So here we have P delta V. So what I'm going to do, in place of this P delta V, what I'm going to do, I'm going to substitute this value. So we can write this work done, which is equal to N or delta T. Now we have all the information. The number of moles of gas here they mentioned as 3 multiplied by the gas constant value is 8.314, right? Or we can just take 8.314 or 31, it's up to you. Multiply with the delta T. What is the value of delta T here? 15. So let's wait for getting the answer. 3 multiply with 8.314 multiply with 15. I got the answer as 374.13 joule. So this is the answer for the first part. Now we are going to calculate what is the heat energy transferred. So for getting the answer for the B part, and this process is a constant pressure, so we have to use the rule NCP delta T, and the gas is the monoatomic gas. So the CP for monoatomic gas, so the CP value for the monoatomic gas is 5 over 2 times of R. So I have to take this CP and substitute the value here. So by that, the above equation will become N multiply with 5 over 2 times of R multiply with delta T. Now I'm going to substitute the value. The number of moles here they mentioned as 3 multiply 5 over 2 multiply with the gas constant 8.314 multiply with the change in temperature they mentioned in the question as 15 Kelvin. Now I'm going to calculate the answer for the B part. So the answer is 935.33 joule. So this is the answer for the second question. For the third question, we are going to find the change in internal energy. Change in internal energy, you can get the answer in two ways, either by using the first law of thermodynamics, or we can use molar specific heat at constant volume. So we know NCV delta T. Or you can use the first law of thermodynamics. Let's we try for that also for cross-checking our answer. Okay. So first of all, I'm going to use this rule, and the CV value for monoatomic gas is 3/2 times of R. So I'm going to substitute this equation here. So by that, this equation will become N multiply 3/2 times R delta T. I'm going to substitute the value. So the number of moles here is 3, multiply with 3, multiply with the gas constant 8.314, multiply with the change in temperature is 15/2. So I have to calculate 3 multiplied by 3, 8.314, multiplied with 15/2. I got the answer as 561.2. 561.2 joules. The change in internal energy equation, the value is this one. If you want to use the first law of thermodynamics, let's we try for that also. Or you can use the first law of thermodynamics, Q, which is equal to the change in internal energy plus work done. So now I'm going to calculate this internal energy. The change in internal energy is equal to Q minus W. So I'm going to take the answer of Q and minus the value of the W. What is the Q value? 935.33. So 935.33 minus, and the value for the work done we got here is 374.13. 374.13. Let's check one more time. Yes. So now I'm going to subtract this value. Let's see what is the answer. 935.33 minus 374.13. We got the answer as 561.2. Same answer. So either you can use that equation or the first law of thermodynamics. Clear? First law of thermodynamic equation you already know. You can use that equation also for getting the answer. So either you can use this relation or this relation. So both give the same answer. Okay, now we have to go for the last question. What is the change in average kinetic energy per atom? So for getting the third answer, as we already know, the kinetic energy average is given by the rule 3/2 times of Kt. So Kt is nothing but here delta T, right? And here Boltzmann constant K takes the value of 1.38 multiplied 10 power minus 23, which is a constant value, and the unit is joules per Kelvin. I'm going to use this value, and the delta T value already given in the question as 15 Kelvin. I'm going to substitute the value here. So 3/2 multiply with 1.38 multiply 10 power minus 23 multiply with this 15. I got the answer as 3.105 multiplied 10 power minus 22 joules. So this is the answer for the last question. Clear? That's it. Thank you.